Hello, my dear students. I hope you all have been doing well. Today we are going to start our lecture number 16, and it is about ethers part 2. In first part of ethers, that was the lecture number 15. We studied about what are ethers, what are their physiochemical properties, and what are the biological activities of ethers, and how we can name them. However, in this lecture, we are going to study about the general method of preparation of ethers and how we can identify ethers in the laboratory, and what will be the pharmaceutical applications of ether, and what will be the medicinal application and other journal applications of ethers. So starting from the synthesis of ethers, we can produce ether in our lab by the dehydration of alcohol, and dehydration is the process of removal of water from any compound or any uh, mm, from any during any chemical reaction. So here means in the case of this reaction, we can produce ether from the dehydration of alcohol. So here we can see the alcohol when um, um, alcohol can produce ether by removal of water. So this reaction required an elevated temperature and a catalyst, that is sulfuric acid, and by this reaction we can produce symmetrical ether, uh, but the non-symmetrical ethers cannot uh, readily formed by this process. However, cyclic ethers cannot be formed by this process. And what is this symmetrical ether? I have told you in my previous lecture that if in ether functional group, if the oxygen atom is linked with two similar alkyl group, or two same alkyl group, that will be the symmetrical ethers. So by this process, we can produce ethers uh, uh, from the alcohol. When we dehydrate alcohol, when we remove water from alcohol, in the presence of a catalyst, there may be sulfuric acid at elevated temperature. So we will get symmetrical ether as a product. And the second method of synthesis of ether is the Williamson ether reaction, or Williamson ether synthesis. In this Williamson ether synthesis is an organic reaction, that is form an ether from an organohalide and a deprotonated alkoxide. The organohalide is any organic compound, that is alkane, alkene, alkyne, that is having uh, a halide group in its structure. So, and the alkoxide is the conjugated base of um, al- alcohols that are having linked uh, that are having um, a negatively charged oxygen that is linked with the molecule, and this reaction takes place in the presence of sodium hydroxide. Another method that is similar to the Williamson reaction is Ullman condensation. Uh, this method by this method we can synthesize ether from aryl halide. So in this method, the substrate is aryl halide rather than the alkoxide, as an in Williamson reaction. However, ethers can also be prepared by addition of alcohol to the electrophilically activated alkene. So what this is, electrophilically activated alkene Electrophilically activated alkenes are those alkenes that can be participate in electrophilic substitution reactions. So when we react with electrophilically uh, activated alkane with alcohol, this is an alcohol and this is electrophilically activated alkene. When these two substrate react with each other, these two reactant react with each other, they form ethers. For the identification of ethers in laboratory, what we do, we react a mixture of a sample with an acetic acid and hydrogen iodide. What we do, we use a sample that is having ether and then we react this sample containing ether with acetic acid and hydrogen iodide. So what we will get after this reaction of ether with hydrogen iodide, we get uh, an alcohol, an alkyl iodide. So when we react this mixture again with silver nitrate, so we will get silver iodide precipitate. At the end of this reaction, that will be the identification of ethers. Now going towards the application of ethers, ethers can be used as an antiseptic, disinfectant, as an anesthetic, and they may be used to induce euphoria and sedation. So, as an antiseptic and disinfectant, ether use prior injection, ethers, liquid or sprays uh, are used um, as antiseptic and disinfectant uh, before uh, before injection or after injection to clean the injected area. And in hospitals, diethyl ether is used as anesthetics to unconscious patients of operations. And as ethers are slow release product, so they can be used to induce euphoria and sedation. Euphoria is the feeling of happiness in pharmaceutical industries or pharmaceutical preparation, like in the preparation of capsules and release medications, the ethers used as excipients. A well-known example is HPMC. Here we are having the structure of HPMC. What is it? This HPMC is a ether based matrix, and we call is as hydroperoxy proline methyl cellulose. It is having a ether functional group, as we can see here. As when we rewind the application definition of ethers, what are ethers? As I told you in my previous lecture, ethers are organic compound or organic molecules that are having an ether functional group. And what is that ether functional group? An ether functional group is that is having an oxygen atom linked with two alkyl or aryl group. So here you can see this is the structure of hydroxyproline methyl cellulose HPMC, and here you can see that this cellulose is having an ether functional group, uh, where an oxygen atom is linked with two alkyl group. So what this how this structure or this ether-based molecule used in pharmaceutical industry. Actually, this molecule is like a matrix. It is used as excipient in slow release medication or sustained release medication. So what it do there as a matrix, when we use this to prepare slow release medication, So it will allow what it will do, ether, what ether will do, ether matrix will do there, it will allow the uh, active ingredient of that drug or the capsule to be released slowly in the bloodstream. So it is very much important pharmaceutical application of ethers and other ether that is uh, that is important as a pharmaceutical application is the dimethyl carboxymethyl cellulose and carboxymethyl cellulose. This is the structure of diethyl carboxymethyl cellulose and it is having an ether functional group. So where we use this molecule in the preparation of pharmaceutical, we use these molecule in the production of tablets and capsule, or it can be used for the coating of tablets. As a pharmacist, we all know it some drugs are available as sugar coated form. So why we coat these tablets? Because we coat this tablet, we want to make them slow release product or sometimes we wish to mark their taste. So these in this two purpose, this diethyl carboxymethyl cellulose and methyl ethyl cellulose used um, as you can say this is used as ingredient to coat the tablets or to enable the tablet to be slow release from the pharmaceutical preparations. So dear students, these are my some books. You can consult from these books for further readings about ethers. And these are the web links. You can go through these web links and you can read more about the mm, ethers. And it is here is a research article. You can also go through this research article for further reading. And thank you very much for your kind attention and be safe from COVID-19. Allah Hafiz.